All right, so what I'm going to do is I'm going to explain how mod bundle works and why it's there, right? This is going to be a messy explanation. So, all right, so basically, so there's this functionality where you can bundle a bunch of modules together, the bytecode for a bunch of modules together into a single bytecode file, right? And so if you have modules that have this dependency in Jack, so basically this module imports that module and this module. Jack lets you use Jack build. If you run Jack build, you can essentially take all of these Jack file modules and then you essentially generate you generate bytecode. I'll do bytecode like this for each module all at once, right? So you have all the bytecode, and then these bytecodes, I need to turn my mouse sensitivity down. These bytecodes become, like all of these can be kind of put together into like a single file called a JIR file that will have like all the bytecodes in it, right? So these are all 3 bytecodes, is all in one file. There's other stuff in this file, which is cool, but then this becomes one kind of statically built bundle, right? So I call these the bundle. Now, when you start executing, because this is pure Python bytecode, when you start executing this bundle, let's say this particular one is where your main starts, okay? This is actually the main entry point of your function. And then at this point, there's an import, right? And it's importing something that's in this bundle. When you're executing Python, your imports are going to start looking for a file, and then dynamically by default it'll start dynamically trying to convert that Python file into bytecode and do that dynamically. But here we just want to reroute that import to just go straight here and not out to disk for a file, right? So we don't want to do that thing. We just want to reroute it internally, okay? So mod bundle is used for that. So the Jack import function, if you call Jack import with a mod bundle parameter, it's going to execute the bytecode directly compiled already from within this bundle file, right? So if you want to see what that looks like, so of course we generate mod bundle stuff, right? So in CodeGen, this becomes a module level global variable, you can think of it, of every module that's generated into the Jack code. And the Jack import, where's Jack import? It's a importer. So this Jack import has an optional variable that is the module for mod bundles. And so right. And so basically on that import, the mod bundle is pointed to its actual the actual module code. You can read this code to kind of really get a sense for like what's happening with this mod bundle to make that work. But basically, if there is a mod bundle passed, it'll look up the code object from that bundle, right? So the bundle is really the pointer to the collection that would have that module, right? So you can kind of see that code here on the Jack import thing. Now, this mechanism, this mod bundle could also include all of the fancy schmancy meaning typed representation. So you can, I'll just do them as diamonds as the type information stuff. Jason Lucas is calling me. So let's see. So basically, you can have this information here and then leverage mod bundle to collect it, right? So, and all of this will be accessible everywhere. So we can piggyback on that mod bundle abstraction. Now, what I'm thinking to myself is, this is a Jack only feature, right? And so is that okay? And I've determined in that last millisecond that it is okay, because the whole concept of sem strings is a Jack only feature. So we're safe, right? The meaning type to everything is a Jack only feature. So it's only Jack code. Is this true? It's only Jack code that we might want to. I think it's good for V1. Yeah, it's good for V1. Maybe there's some fancy schmancy thing we could do for like legacy Python only code. But the truth is, now with Pavi's stuff, Python only code becomes Jack code in the bundle. It's wild. It's actually wild when this is done. But anyway, okay. So that's my little spiel on perhaps what we could do.
So,
Yeah. Good.
so,
Yeah, go ahead.
like, so is this happens only if we use Jack build? If I run Jack run, does it work?
Yeah, when you run Jack run, it works like Python because these are all none. Yeah. So
Then there's issue.
no, not necessarily. So let me explain. So there's not an issue because you would end up building these dynamically, you know? So all right, this is one part. It's one part of the implementation that deals with this bundle piece. And it's important for how do we store it if we have the notion of compiling. Because right now, okay, now the other thing is how do you load it, right? Because that load function, which would be, like how do you access it? How do you use it, right? And to access it and use it, my instincts tell me it comes from the, like, it'll be one of these, right? So I don't know what you guys have implemented so far, but it would be essentially something like this would load it and would then be able to be called whenever you want to do your meaning type AOT raise or something, right?
Yeah.
And I would think in construct you would have like some kind of global repository of these modules, these stars. In construct you could have like a repository of these stars, right, that lives with the execution. Does that make sense? It's yeah.
So if we create it like this, so like let's say like we went with this method and like these all the registry stuff are bundled in, and so the user always has to Jack build in order to run these LLM features. He can't just Jack run.
Yeah, so yeah, we will be able to Jack run because what happens on a Jack run, okay, let me, I think another good way to put it would be like this. Let's talk about Jack run. I'll just do a new picture. Let me just do it again. It's all good, it's all good. Let's talk about Jack run. And I'll just do this for simplicity. And I'm going to kind of, I have it somewhat messily in my head. It'll get clearer when I explain it, while I explain it. Okay, so we have a Jack run and then we have this import, right? This module imports this module. Okay? Now, when you do a Jack run, what happens is this module is loaded from the disk and then it's turned into bytecode that is then executed. Now, this bytecode, when we do this fully dynamically, actually turns into a module in sys.modules, right? So sys.modules sys.modules will then have, let's say this is called M, it'll then have an M in it, okay? This is M. So this happens dynamically. And then when this starts executing, okay, then when this starts executing, it'll hit an import, and then it'll do the same thing again, right? It's going to create the bytecode, and then it's going to go into sys.modules, right, as M2. And then it's going to start running from there as M2. Now, sys.modules is designed to only hold modules and the code that can run. But we can have a global in construct. I'll just type it like this. You can also imagine we generate the star, and then we stick the star into our plugin, right? And we can call it construct, I don't know, dot modules, or like dot sem modules, or module sem, right? We could do sem mods, or mod sems. Mod sems would be better, but whatever, we'll leave it like that. Can have M. And then we'll do the same here dynamically. Construct.send. And so this will be a plugin, right? Like this will be one of those plugin calls, right? Construct.sem mods. This will have M2. Jeez, handwriting's going in the toilet. Okay, so then this will also dynamically. So dynamically, we'll be building up these at the same time, right? And then whenever you do your LLM meaning type stuff, you just look it up from this construct.sem mods.
Okay.
Because
So like
yeah,
this will have some other, like, okay, so the approach we had is like, okay, in the AST generation we create something like a code or the bytecode or whatever, and we at the same time we create these our JSON files, okay. So, and when we are running it, okay, we don't think about creating these things again. We just access them. So, but now if in this case, if we are just running it and we build them dynamically, so this thing had to be created while we are running it, and we had to access it while we are running it. Like, wouldn't be too much, because the Jack build thing makes sense. Because
it's cache.
It was created when in its building, and because the registry thing doesn't change when it's running, because it's a fixed thing. So it's like, so when the AST is getting generated, it should be happen, don't you think?
Yeah. So this is that's a really good point for us to double click on. So your instincts are correct. Doing the work dynamically feels like too much, but indeed that's actually what always happens with Python. And what they do to mitigate it is to create cache files. Because that AST build actually happens every time you run Python. Just if we just think about Python land, the building, the formulation of AST and all that stuff happens every single time you load the file off the disk to run it. And then Python will create cache files. And we do that too with the jackgen folder, right? And so you could we jackgen cache this, and we also jackgen cache this, and then sometimes we'll, for debug purposes, just generate this and put that in jackgen for fun, the Python, whatever. But like, so this is the bytecode that gets cached, JBC files, and then you could add a file called, I don't know, jsemmod JSM files. I don't know, JMS files. So you can actually cache those too. So I agree with you. Like, when you run the same program twice and you don't have to, there's no changes to the file, you could just use the cached version without doing all of that compilation. And so, yeah, but this happens the Jack build you're talking about, that feels like the right place to do the work of building these diamonds, building the SEM infos. That even just that AST Jack building happens every single time you run if you don't cache. Similar to Python. Does that make sense?
Yeah.
So this is kind of in line, right? Similar to generating basically every time you can generate bytecode for a module, you can generate the SEM. We got to come up with names for this stuff, but the SEM info per module, the mod SEM info. So you just build these at the same time.
If you ask me, like, so there is no difference between this and JSON now.
Yeah. Well, the cached. Okay, the way that you guys are doing the JSON, to your point, the way that you guys are doing the JSON it is a representation of a cached version, like a JBC file. But it's only a cache. It shouldn't be on the critical path. So there's a couple things. Number one, JSON is a nice. JSON is it's nice because it's a generalized ways to serialize things. It's unnice because it's not strongly typed. It's not type safe. So I don't like the lack of type safety of just a dictionary representation to make it nicely JSONable easily. So that's one critique that I think we should move away from. The other thing is you don't have to do that round trip to disk, right? Unless you're loading, you should reason about it as a caching function, not a execution function. But yeah, you're mostly right that the JSON is not very different than the idea of what I'm talking about, like a cached version of this diamond. Yeah. Watch this video again. Yeah, watch this video again, and it'll click even better. I promise. But I think that's the way we should roll.
It's true. We should go for a different approach. Like JSON is not gonna work all the time, but it's not beautiful enough. But what we can actually do right now, is this approach, what we're trying to say, other than the file itself and how we are storing it, so is working. But what if we have it for now, and at the after everything is done, we convert this at this part?
So what I would do before I merge it into main, honestly, okay, all right, cool. I am somewhat flexible. Here's the way it could get passed for me. The first thing is, I think we need to do the well typed kind of representation of the sem mod info, whatever we're gonna call this thing. So we need to do that, and then so it needs to be nicely typed. If for some reason the level of passion for JSON is high enough that we really want to serialize it as JSON, add those as methods to the class. Just add those as methods.
No. I think we should not keep the JSON.
Okay.
That's
you can do
we just had.
Yeah.
We just kept it for the next steps to go through.
Yeah. So, gotcha. So you could just make it pickle for now or something, right? You could just pickle those objects for now. Yeah. So
that's even fine. That's fine.
Okay, good. And then we get the nice type safe stuff. And then if you did that and you put it in JackGen, I would go with it. I wouldn't. Don't worry about. I'm probably going to implement this. let me implement
Yeah.
like, because honestly, this actually always happens as a, this is a, the main implementation is really the one that's like this, the Python cache thing. That's the main implementation. So I would definitely merge it in with that, and then I'll probably code this unless you guys really really want to, which I'm happy to help guide you through. But I don't mind doing this one because this one's really complicated. So
And at the same time, so right now, as you mentioned, like we have this issue if there's an import in the middle. So how do we solve that?
oh, the import in the middle. Okay, okay. That, yeah, we didn't talk about that yet. We didn't talk about the that aspect of the PR, right? Which is and it's because of, what was the line? It was in the modules. Yeah, in the modules. Okay. Wait. Oh yeah, it's this guy. Okay. So oh, this one is basically you would want to move all of this into its own pass. And so basically, actually you don't have to. Like, I'm sorry, I was just thinking about the solution. You technically don't have to. I think we should. I should probably just say like let's do that. Because you're essentially adding this functionality to CodeGen, and it's actually not really CodeGen. Let's make it its own thing and call it like, what did we call it? SEM management class or something? SEM management? I don't know. You come up with a name, move it into its own pass, add it to the schedule, you know, whatever, just add it to the schedule, whatever. But the way
it's going to be before PyST Gen path.
Right.
Still
I know. Yeah. Sorry to cut you off, but I know. Let me get to that part of the solution. The way you solve it algorithmically is, so you have your pass, right? So, and this is I'm just pseudo coding it, but you have your pass, and right now you have like registry, right, as a field. You have registry as a field, probably regis, there's an I in there, whatever, as a field. What you want to do is on enter mod, you would essentially just implement enter mod and exit mod. Fuck, you'll have to make it a stack. Shit. Wait, no. You don't have to make it a stack. This is not. Don't. Yeah. Okay. Here's the solution. I'll do it in Notepad. So in your pass, you should have a field called current mod. I'm just trying to think, is it going to end up being a stack? Oh, because what I'm trying to do is basically, what I'm thinking out loud is like, in enter module, you would just do like current.
Can't we instead of using module, okay, we'll use the exit module. That's fine. But for let's say for every exit assignment, so from the assignment node, can we get the module of that assignment?
No, I know. No, we can't. I understand what you're saying. Not while we're traversing the tree, unless you use something like current mod. This is how you do it, right? So the current mod as you're traversing the tree. So on enter mod, exit mod, you can set your current mod, and then it's like current mod equals parent, whatever. And this is why I'm thinking it's a stack, right? And then when you're in exit assignment, right, exit assignment would always just be, current mod, create registry or whatever it is.
Yeah.
Registry. So this is one. I've thought about having every node connected to its. Okay, so for every solution, there's like 10. For every problem, there's like 10 solutions, and I'm just debating which solution is the most elegant. So that's why I'm always kind of hesitating. This is a solution. Maybe your current mod is a stack. Maybe there's a clever way to not make it a stack. Another solution that's slower but more beautiful would be to use what Kugation just implemented. This get parent module of type. Get parent of type. Remember? In pass? That would work. I mean, it's very readable. It's beautiful, but it's slow. What was it? Oh, we didn't merge it in yet. But wait, was that with me and you and Pavi? Or was that me and you and Chandra? Oh, okay. So Chandra's never seen that. So you know how we have get all submodules of a particular type? In another PR, Kugation added get parent of type. And so it's going to get the first parent of a certain type. It'll just go up the tree and find the parent of a certain type. And you could actually do get parent of type module, and then you'll actually get the module. So there's a couple solutions, right? I would accept any of these. I think this is fine. Yeah, this is nice because it's modular and it's encapsulated into one pass, and then it's clean. So you could use something like this. But you just want to keep track. These enter and exit really. The reason why it might be a stack is because you might have multiple enters happen, and then you just want to exit. Yeah. So this could just be a stack. You could make it a list, right? And pop from the back of the list or something. But anyway, yeah. All right.
So,
yeah. Go ahead.
Yeah. So I think we can then work on the registry PR, this PR, and implement that, and say instead of saving it as a JSON, we save it as a pickle or something like that.
Yeah.
Okay, we can do that, but everything else will work as same because Janak is working on it.
Yeah.
Then we will improve it.
Right.
After this is merged, we can go for the rest.
Sounds good. That's perfect. And I'll merge it. And then the rest would be the part when I was talking about this thing, this construct thing. So think about that. Like when you watch the video, you could we could look at this piece again and then think about what the hell I mean and then ask me questions.
Yeah.
Yeah. Awesome. But that's a good next step. And then I'll merge it in.
Sure.
Cool. Awesome. All right, man. I'll upload this and we'll take it from there. Yep.
Yeah, and I also merging that Bobby's PR.
Oh, okay. You want to talk about that? Oh, yeah. Let's talk about that.
Yeah.
Okay. All right. I'm gonna close this video and then we could talk about that. Awesome.